So I'm sure you've all got views on the outcomes of COP26 and the plans and commitments. So before we kick off with our first panel session, we've got a little bit of time for a quick audience poll to gauge our position as an engineering community on this topic. The question that we've got for you today is, in your opinion, are the commitments made at COP26 option A, achievable with the national plans and strategies currently in place? Option B, achievable if national plans continue to be developed at pace? Option C, achievable only with more significant changes in how we develop and implement policy in this field? Or the final option is unachievable within our current systems. So the poll should be available below the live stream for you to select your answer. So have a think. I can see some people are already starting to respond. While you respond, we've got a short video to introduce this topic further. And I'm sure that you'll notice the echo of many of the key points that we've just heard from Professor Monks. So let's take a look at that video now.
In 2019, the British government committed the UK to achieving net zero greenhouse gas emissions by 2050. Over 130 countries around the world have pledged to hit the same target. It's a highly ambitious deadline, and it needs to be. Delaying action on emissions risks runaway climate change. At the same time, choices we make now will live with us for decades or centuries to come. It is important we act now, and it is important we get this right. This series of video explainers will explore how we navigate our way through an increasingly complex and connected modern world to reach net zero, in line with the Paris Agreement. We call this joined-up process a system transition, and it's how we get to net zero. Nicholas Stern is a former chief economist of the World Bank, who hit the headlines in 2006 when his Stern Review on the Economics of Climate Change was published. The 700-page report laid out in stark terms the devastating economic toll that climate change would have on the global economy if left unchecked, and stressed the economic benefits of early intervention. 15 years later, net zero remains at the top of Stern's agenda.
If we're going to stop temperatures rising, we've got to go to net zero. And to get to net zero emissions, we have to radically change in real time, just 2 or 3 decades, the way we run our economies, and that first decade will be absolutely decisive. But when we look at that challenge, actually we will be discovering and creating a new form of economic development, much cleaner, much healthier, much safer, and much more productive than has gone before.
But government setting an audacious goal is one thing. Making it a reality is a far bigger challenge.
We have really the biggest transformation the world has probably seen in a peacetime economy, with enormous progress required this decade. But you've got to invest to get there, you've got to change quickly, you've got to manage that change, changing in the very big systems of cities, energy, transport, land, and of course a big change in the overall system of the way the economy functions.
Achieving net zero is a massive systems challenge. It's going to involve simultaneous transformation of a whole range of vital and interconnected infrastructure systems, from transport and housing to energy and manufacturing. So we absolutely have to take a systems view to understand interdependencies between those different components of a system, understand where the trade-offs are that we're going to have to make, opportunities for leverage and incentivising the right behaviours so that we can align all these different factors towards this singular outcome of net zero.
A systems perspective shows us the crucial connections between the systems upon which we depend. Infrastructure systems around the globe rely on natural resources and ecosystems for their materials, energy, and safe operating conditions. In turn, our infrastructure systems depend on and support each other, so when we make a change to decarbonise our transport system, it also changes what we need from our energy system and from our built environment, and vice versa. Making good decisions for any of these, and especially making decisions that protect the ecosystems they rely on, requires a strategy for all of them.
Without a framework for joined-up policymaking, finite resources such as zero carbon electricity supply or the rare metals that we need for key technologies such as batteries are not going to be available when and where we need them. So we end up in a position where we could be in this macabre version of whack-a-mole, where we reduce emissions in one place and then they pop up somewhere else in the economy or perhaps in another country. We deploy new technology but we don't have the right structures in place to get the benefit. You can end up creating more problems than you solve.
Engineers are often the people building, operating and integrating all the parts of these different systems: transport, energy and buildings. Engineering skills and systems thinking are needed to bring them together to create a net zero future that works.
Engineers are innovators, problem solvers, systems thinkers. They're fundamental to fully realising net zero anywhere in the world. And the systems approach is really core to engineering. It's what we sometimes call one of the engineering habits of mind. And it provides us with this structured, disciplined approach to managing complexity. It's like a toolkit that we can use. Engineers can also use systems approaches to handle less tangible products and to help us cope better with uncertainty. So it's really important to remember that when we talk about systems, we mean socio-technical systems. We need to think about how systems work in the real world, interacting with people and planet.
Implementing net zero is an unprecedented and all-encompassing challenge of delivery and integration. Engineers will need to collaborate with other disciplines, policymakers, and crucially the public to guide the transition in a sustainable and just way for all.
It's a combination of science, engineering, public policy, city planning, town and country planning. It all has to be put together. So you need the systems engineers of the really technical system engineering kind, because these are complicated engineering systems. But at the same time, you need the systemic side of society, economy, government to make this happen. And the government side is critical.
Before we go into those themes further with our panel discussion, let's have a quick look at the poll results. So that's interesting to see. Most of you think that this is achievable, but we need more significant changes in how we develop and implement policy in this field. So I think it's good to see that we all recognise the challenge, but I think there is quite a lot of optimism needed to help us to get there. So it's good to see that people haven't given up already and decided that this is not achievable. So we'll probably pick up a bit on that during the session. So let's get started. I'm going to introduce all of our panel members for this morning. We've got Professor Becky Lunn, who is a research chair in biomineral technologies for ground engineering at the University of Strathclyde and a member of the National Engineering Policy Centre's Net Zero Working Group. Our second speaker is Professor Peter Lund. He's the Professor of Engineering Physics and Advanced Energy Systems at Aalto University and co-chair of the recent SAPEA report, a systemic approach to the energy transition in Europe. We've also got Professor Christoph Schmidt, President of RWI, the Leibniz Institute for Economic Research, and co-chair of the SAPEA report along with Peter. And our fourth speaker today is Yves Bombarger, former Director of R&D at EDF, a Fellow of the French National Academy of Technology, and chair of the Cates Energy Committee. So I'm going to kick off by giving each of our speakers 3 minutes or so to introduce their perspective on our topic. And just a word of warning, I may cut you off if you're going over the time, just to make sure that we have enough time for discussion and questions at the end. So let's kick off with Becky, please.
So good morning and thank you for inviting me. It's great to be here. So I'm going to reinforce a few of the points that Paul has made, I think, to start. So in order to meet the challenge of net zero, we need to manage a transition to a low carbon energy system in particular, and that's a huge challenge. So at the moment, renewable electricity accounts for around 20% of total energy consumption. That's even in Scotland. where we have quite a high percentage of renewables for electricity, but we have a large heat demand. But in all of the UK, it's very low. So we have nuclear that can add to low carbon energy, but has long lead-in times. And we need to increase that low carbon generating capacity substantially. And as Paul said, at least double it, 2 to 3 times that capacity. And we also, whilst doing that, need to remove our built-in reliance on hydrocarbons. So some of our technologies, it's not easy to decarbonise and suddenly to transfer over to renewable electricity. We need to reduce our burning of natural gas for heating, and we need to move over from petrol cars to electrified systems. Those two between them account for 75% of our current energy use, and that has to change. So even if we increase low carbon generating capacity by 2 to 3 times, we're still going to need to reduce energy demand by at least 50%. So we need to halve at least our energy demand to meet this challenge, and that's a real challenge. So we need to look at how we use energy in buildings and reduce that, and we need to think about products. At the moment, our economy relies on us buying more and more things. That's a successful business. That has to change. So we need to be reusing and recycling materials in products, using less of them. So where do engineers come into all of this? So engineers, as everybody has said, are experts at managing complex systems. And just to give you one more sort of concrete example, if you like, let's think about decarbonising homes. So we need to reduce heat loss in housing and the demand that homes make. It's a very large part of our current consumption of energy. If you take Glasgow City Council's targets, if you divide the target by the number of homes, it's already, if we start today, retrofitting one home every 19 minutes, which is an enormous rate of retrofit and clearly can't be done by one engineering company. So we're going to require a very large skilled workforce that we need to build up and train very rapidly, but that's not enough. We need volumes of materials in ready supply, so we need insulating materials. Some of those might require some more development as they tend to be hydrocarbon based, so we may need new insulating materials at pace. We need glass, we need PVC, which is currently in shortage, in order to put in glazing and improve double and triple glazing. We need transport capacity for those materials throughout the UK and beyond. We need economic policy drivers. We've got to accelerate a new business really rapidly, so that will require policy drivers, it will require regulation, and it will require new certification schemes to guarantee quality of the job. And also, critically, we need carbon certification schemes, particularly on materials which are mined. They have huge energy inputs themselves. We need to change that process. So we need to be able to guarantee that the materials we buy for this have a low embodied carbon in the future. Currently, there's no way of doing that. So just to sort of sum up, engineers are experts at managing these kinds of complex systems. We need to map those systems out, find the pinch points, and act in a timely way to make sure that we don't set one thing off and then find we can't complete it because something else pops up the back that doesn't allow it. And that sort of thinking can also identify where the really critical and urgent research and development needs are. So, thank you.
Thank you very much, Becky. Let's go to Peter next, please.
Okay, thank you very much for the kind invitation to be here today. In my short talk, I would take a perspective from the SAPEA report, and those who don't know what SAPEA stands for, SAPEA is the Science Advice for Policy by European Academies project, run by 5 major academies in Europe, being part of the science advice mechanisms. The SAPEA Working Group on Energy provided a report on a systemic approach to the energy transition in Europe just recently, and clearly indicated that we need to consider concurrently 3 major elements in order to be successful one in the energy transition. Naturally, technology is one of the core elements indeed, and important for the transition, but you need policies and you need proper regulatory mechanisms to pull the technologies into the market. And thirdly, and we think is increasingly important, and we already heard today, are the social dimensions of the transition. This transition, taking its magnitude, is a huge socio-technical transition which touches every people, everyone in Europe and on the globe actually. And that's why the social dimensions, being for instance the social behavior or social acceptance, or in some way coordinating the millions and millions of decisions that we need for clean energy as an example, or that those elements will be extremely important. So this trinity, technology, policy, regulation, and social dimensions, this is like a clockwork, and the different elements are the gears, and as you realize, the clock don't move forward if the gears are not synchronized. This synchronization of these three elements so that the clock moves forward, transition moves forward, that actually is one of the core issues of the systemic change that we need. And that's of course the major challenge that we have here. Sapea in its report touches many of the elements of the systemic approach. And if I look just on some of the technology issues that we have in front of us because of the major technology changes that we have, is that we see, for instance, that the energy system, which is now almost completely fuel-based, will change in a few decades into a weather-dependent, data-dependent, material-dependent energy system, which is a huge challenge for engineers indeed to master. We think this issue of energy system change, the questions of integration and system aspects just on the technology level will be very important. So from an engineering point of view, it will definitely be important that engineers will be able to be one of the gears in the clock, and we understand the different disciplines. We understand the social issues and the adaptation with social aspect that we need to look on. But we also need to link ourselves to the regulatory framework that exists. In that sense, I think engineering can be very, very successful one. But to be concrete, what kind of questions do engineers typically provide answers to? Well, very important question is what is possible? What can we do? What cannot we do is very important. And maybe for the future, what can we do? So these very fundamental questions, which I think policymakers will need when they do decisions, who else than the engineers could provide? So with this word, I hand back to you, Jasmine. Thank you.
Thank you very much, Peter. Christoph, over to you.
Thank you very much. Thank you for the invitation to provide insights from the discipline of economics and from the social science more generally into the question of how we should be able to put sustainability and net zero at the heart of economic growth and economic recovery across Europe. I think there are two elements to be discussed. One is the conceptual prerequisites, the principles to follow. And the other element is to draw concrete conclusions from this. Let me start with the principles. I think that every speaker so far was in agreement that we need a systemic view, but I want to stress that the particular challenge is not that it's a multitude of interactions that we have to observe, that it's an extraordinarily dynamic system that we are observing and analyzing, but it is inhabited by a multitude, a myriad of actors, households and enterprises who follow their own objectives, their own preferences and constraints. They have their own will. So understanding their decisions and framing the environment in which they take these decisions is mostly important. So it's a socio-technical system with objects forming that system, combining into that system, which have their own will. So policymakers cannot follow a detailed plan. They must humbly set a frame for private action in a learning system. That was one prerequisite. The other prerequisite is the global ambition. All European progress is ultimately futile if it does not effectively lead to mitigating climate change on a global scale, and we cannot do it on our own. So policymakers need to administer a European transition towards climate neutrality which incentivizes sufficiently many other nations to follow suit. What does it mean in the concrete? Well, the policy package that is framing, that's providing the frame for individual actions needs to be holistic and encompassing and internally consistent. And it needs to fulfill several requirements that we address in the SAPEA report quite clearly. It needs to be effective. That's no contest, actually. Nobody will follow you if you don't fulfill your own objectives. But it also needs to be efficient. It needs to avoid wasting economic resources, because if you pay more for defossilization than you need to, if you waste economic resources, they are not available to other uses. And the guiding policy instrument that we identified is carbon pricing. Of course, augmented by the right things, by infrastructure investments that make the carbon price unfold fully to its full extent. But carbon pricing needs to be in the middle. And of course, engineering is helping everybody or the whole system to lower that cost by technical progress. No contest about this, but it's a socio-technical issue. And that leads to two more requirements. The transition needs to be socially balanced, because all climate policy is in itself regressive, in the sense that low-income households use more of their budgets for energy sources. So making energy more expensive, which is the way to go, either by price measures or non-price measures, it will cost economic resources. This is regressive. So we need to compensate low-income households. We need to engage them in participation schemes to preserve the acceptance. And finally, we don't have to, or we cannot risk to lose our own prosperity in the process. Carbon leakage will not help anybody, because the climate will not be helped. And loss of prosperity means nobody will follow you whose own prosperity is still to develop. So we need climate alliances. We need the global alliance. And that is something that is the second requirement. Systemic view is fine, but it needs to be a globally systemic view.
Thank you very much. And last but not least, over to Yves, please.
Thanks. Hello, everybody. I'm really happy to be here with you. I will look at from another point of view. We say all engineers are important, but it would be better if the other citizens and policymakers say that. It means I will shortly speak about the magic triangle, engineering, policymakers, and society. I think we don't have to forget that the trust in engineering and science has decreased, and I'm not sure that the outbreak is increasing. I think it's exactly the contrary. We have to work on the trust that policymakers and society may give us. And for that, we have to be very clear and to be very modest, saying what is known, uncertain, what is not known. I would say saying the light and describing the lights and shadows of technologies, how it's done in Kyoto every year at the STS Forum. That it was my first point. My second point is that we speak always on innovation. We never mention progress. For people, innovation is somehow often relatively boring, but progress is good. And I think we have to remain to everybody what has been done through engineering, technology, and science these last 100 years. And I was listening, all of you. Only Sir Stern was mentioning progress. You never mentioned progress. I think we have to mention again progress to show the policymakers and the citizens that engineering and science are bringing progress. And last point, I think also we have to address the ethical questions. Pushing energy efficiency first, I think, is not exactly the same than pushing low carbon or low emission first. And I think to be inclusive, to think to poor people in cities or in emerging countries, saying energy reduction that it's not acceptable. Even more if we think again that all is limited on our planet, but energy is not limited because the sun is sending us 8,000 more energy that we need. So the question is decoupling energy and energy use and environment and emissions. So I think, to summarize, we have to be modest, to be desired, and to make a little last comment, when we see the governments in our Western countries, in European countries, compared to some others, there are very few engineers. It means that perhaps the trust that have policymakers and citizens in us is not so high, and it has to be higher in the future. And I hope we will succeed to do that. Thank you.
Thank you so much. Thank you for sticking to the time as well. That's much appreciated. I will kick off the discussion with a couple of questions, but I would love to see your questions, all of those audience members who are watching. So submit them via the Q&A that's at the bottom of your screen. I think quite a few of you mentioned the importance of behaviour change, and I think as engineers, it's probably not something we're taught about that often. So what do you think the role of engineers is in that behaviour change side of things? Maybe I'll start with Becky, if that's okay.
So actually, I think the role is significant. So people won't change behaviours if that behaviour is difficult or expensive to change. It needs to be something that is, I think there is a will to change. I think there's a real society will to change, but it needs to be possible too. So, you know, there are many places in the UK where public transport, for example, is not an option, and a car is the only option that you're going to have. Transferring to electric vehicles currently is an expensive option, so it's not something that's available to many people. And if you take Glasgow as an example, most people live in flats, so they don't have the possibility of a home charging point. So we have to think very carefully about what the blocks are. It's all very well asking people to change behaviours, but oftentimes they can't. So we have to think about how to make that feasible, and that's partly engineering and partly policy. A lot of it is policy.
Eve, did you put your hand up? Yes, do you want to come in with?
Yeah, to give a practical example also, when you have some air conditioning system in a car, you could have an automatic system. It means if the air conditioning system is running one day, when you use the car the next day, automatically it's on. That it's a bad solution. You have to impose the people to switch on the air conditioning system when they go in their car, but they are free to switch on or not to switch on. I think that it's a very it's a very little question, very little point, but it helps the people to avoid to use energy and to produce CO2 emissions. That way they are free, but the engineering way help them to reduce the carbon emission. We don't impose them the solution.
Thank you, Eve. Peter, do you want to come in next?
Yes, I think this is a very important question in the sense that behavior will determine if people accept or reject the technology. And in that sense, the role of the engineers would be to make a technology more human-centric, acceptable for people. Take just an example of a large-scale wind power, which cause sometimes problems within the local population, noise problems, etc. Now, what can the engineers do is so far we haven't looked on the solutions, but you could use acoustic materials to reduce the noise. So there's an engineering solution to a grave problem which may hamper the use of wind energy in the future. So I think being aware about these social interactions and having more interaction with the population, ask the customers. Customer is the king always. I think that will be very important. And I think we need also to maybe update our education system. In some engineering schools, I know that they have some social science courses, but maybe in the future we need to have a much stronger, also multidisciplinary kind of education in this respect.
Thanks, Peter. And Christoph?
Yeah, I have quite a different complementary position. Old habits change very slowly. And Peter was indicating that by education you can do a lot, but you have to really wait for a long time to have that work out through the population. Now, economists bring another perspective to the table regarding behavior, namely a reaction to prices and other behavioral changes. So in layman's terms, from an economist point of view, one would speak of behavioral change when people do different things than before. Let's say they use other modes of transport, public transport instead of using their diesel cars, for example. Now, we wouldn't speak of behavioral change as economists if people just followed the alteration of relative prices. So if you put a carbon price on the diesel fuel, and people use more trains instead of their diesel cars because of this, this is the same behavior. You don't need to put any effort into changing people's minds, but you still change their mode of transport. It's more difficult to infuse a sense of responsibility, for example, that says, well, irrespective of the carbon price, I use more trains than my diesel car. One aspect where this becomes really pertinent is the rebound effect. Should we incentivize people by carbon pricing, avoiding the burden of higher prices by using more efficient modes of receiving a service? That would be our suggestion. And we discussed at the SAPEA group very intensely whether efficiency standards could deliver the same behavioral change. And the answer is no. You might think that given the behavior, more efficiency or better efficiency standards mean lower use of fossil fuels. Well, but cheap people understand that the service they receive from this is less expensive, so they demand more of this. So they somehow eat up, they nag. This is nagging off of the original impact. So you need to go to the behavioral sciences to understand behavior. That's our message.
Thank you. And Becky, do you want to make a comment on that?
Yeah, just one brief thing to say is that engineers have a bit of a track record and there's a lot of well-publicised track record, I would say, of designing for men. And if we wish behaviour to change, we need to design for a much more diverse population than we currently do. It needs to be easy and the right choice for everybody to make, not just a few.
Thank you. That is a very, very good point. Just picking up on another subject that a couple of you mentioned on carbon pricing, and I hear this a lot, and I wondered if you have views on why we haven't got this yet. So I don't know if someone wants to, maybe Christoph, I don't know if you want to start on that one.
This is really a tough question, actually, since the case to be made for carbon pricing is so clear. We are so rich in the world. We have escaped, in many parts of the world at least, escaped dire poverty that has plagued us for centuries because of the division of labor. And division of labor is labor that is used to produce in different places different things. Everybody is specializing, is working in a market system, and that market system needs a market signal, and that's a price, a uniform price. And the same here. The case for carbon pricing is we could use division of labor to have as little cost as possible for decarbonization. Why isn't it flying? Because it makes transparent how costly the whole affair is. And policymakers, for good reasons, are shying away from complete transparency so far because they hope that non-price measures might be less expensive. But if you look closely, they are not. Typically, they're even more expensive and more socially unbalanced. So more transparency is key.
Does anyone else want to comment on that question? Peter?
Yeah, I think definitely this is one of the key questions that we have for the energy transition. And I have two viewpoints that also came out of the SAPEA report. One is of course that we need a global, let's say preferably a global carbon pricing scheme, and one country or one continent just going alone is not the solution. And you need of course to have mechanisms for a fair solution globally. The second point is of course the question about the justice, in the sense that very often those who are the weakest and poorest in society may actually suffer from raising prices, and we need this socially just mechanisms which compensate for these changes. We have in Europe nowadays 30 to 50 million people who can't afford heating, and I think that's why we need to think about carbon pricing also in a socially just frame in Europe and globally, and that is tough, where maybe the richest need to share some of their wealth with the poorest one, which we know is one of the let's say key ethical questions that we may have in this transition.
Thank you, and I'll hand over to Yves for a final comment on this question.
Yeah, briefly to complete what Christoph and Peter were saying, even if we increase many prices and costs to the carbon tax, which will be good, why we don't give back the money to every people equally, to all people, to all citizens in the country, in the different countries? Because finally, that's a question for everybody. Like Christoph was saying, we have all to be active, and to be active, it would be good if we have perhaps if many things are more costly, but at the same time we receive money, and we would know how all this money will be used. The money coming from the tax will be used by the government. It would be better to give back to the people. That was my comment.
Thank you, and I'll just, Becky, if you could quickly.
I'll make it brief, but I was just going to say that it's not just about pricing, it's also about accounting. So at the moment, we don't have a unified way of accounting for carbon, and there is no certification scheme. So actually, even if you can afford it and you wish to make a public choice, you can't do it because there's no way of knowing how much carbon is in a product.
Thank you. Okay, I'm going to go to some audience questions. The first one is, does the panel believe that we have the necessary tools and capabilities to effectively manage the extreme complexity levels that we are facing? Who wants to take that one first? Becky.
Go on, I'll have a go. So I think we do, but I think we just have to get on with it. So we will make mistakes. It's absolutely inevitable that in a transition this large, mistakes will be made. But I think the key thing is to get on and start, if I'm being honest, and make big change, see where we slip up, share information from one country to another, and try and do things on a European-wide, at very least, basis as well, so that we can learn in a more productive way, and so that policy drivers can actually work, which it's a challenge if you were trying to do it on an entirely just on a nation basis.
Thank you. Peter, next, you've got your hand up.
Yeah, I would definitely endorse what you said previously, and we should recall that perfect is the enemy of the good, and that's why I think we need to go forward, also to gain experience. This is a journey which we never have done before, and that's why we should also be merciful to ourselves, policymakers, that there may be mistakes done. But we have to take the step forward. I think it's absolutely very important, and I think through this doing by learning, I think we will of course reach good goals. Paul Monk, he mentioned it in his talk that cooperation is important. I would say this is definitely most important. In the northern part of Europe, where I come from, we collaborate very much in energy. We have a common electricity market, and we can share our assets. and it has given such a huge value to the individual countries. So more collaboration, I think, not just in Europe, but also between the superpowers that we have here around the globe. I think that's the way to go.
Thank you. Do you want to go, Christoph?
Well, since we are talking about the issue what engineering and engineers can provide, I think the evidence-based process that we are used whenever we design a product from scratch until marketability is helpful here. We are talking about this learning system, and I think it needs to be an evidence-based trial and error system with a sophisticated trial and error. But nevertheless, we need to communicate to the public that you cannot plan a transition like that from the beginning to the end without any alteration along the way.
Thank you. I think I'm going to move on to some of the other questions because we've got lots and about 5 minutes left. And I'll put this one to Eve. It's about the issue of building trust between policymakers and the public. Could you elaborate on how we might best go about doing this and what the role of engineers might be in this process?
Thanks for this. Thanks for this question. It's very important. It's concerning all of us here, I think, as engineers and scientists and also economists. I think we have to really to be very clear and careful when we are speaking, discussing with citizens, with policymakers, and so on, or giving lectures, conferences to say what is known, what is not known, where are the risks. I think some communities, scientific communities or engineering communities, are minimizing the risks. Or when something wrong is happening, are not explaining clearly enough what was happening, or not recognizing some mistakes which has been done. Or that, coming back to what Christoph was saying on iteration, I fully agree, deeply agree. But doing that, it means also recognizing mistakes. Or give you an example. When we began in Europe the deregulation of electricity, we were saying developing markets will competition will help to decrease the bills. It's exactly the contrary which has happened. These last 20 years, not only in Germany but in France, everywhere, for other reasons, for systemic reasons that we don't have time to discuss now. So we have to recognize that and to explain that and to be modest. So
thank you. And can I get some quick comments from Peter and Becky?
Yeah, I think one of the problems is, of course, that policy and policymakers look on very short-term issues and from maybe a siloed viewpoint. And that may sometimes cause distrust. And that's why I think it's important that we have a middleman here, an ombudsman in a way, which would be science to policy advice. I mean, think about scientists. They don't have vested interest. They as Christoph said, it's evidence-based work that we're doing. It's objective. And in that sense, in this very complex world and complex issues that we have with energy transition, I think that's where the science needs to step in as a important advisor to governments. Well, science to policy advice is not for lobbying something, but we need to replace the lobbyists in that sense with knowledge, evidence-based knowledge, and I think that would definitely improve the decisions. Also give more foresight to the policymakers, what we can expect in the future, what's the best and most efficient solutions. And let me point out that science to policy advice is not, again, lobbying money for science, but it's really to give an advice to governments, policymakers, and they will then do their decisions based on the information that they have around.
Thank you. Becky?
Yeah, I just wanted to add that I think that the National Engineering Policy Centre has supported this actually in having an independent and authoritative voice. And I think when I've spoken to industries in the last few weeks during COP, and there needs to be a change of attitude, to be honest. We need to be sharing information and sharing learning about this. We need to be tackling net zero collaboratively. This is not a competition in between industries. So we need to think differently about innovation and IP and be sharing all of that and managing this transition as a team. It's a massive challenge. Everybody can make money out of this if that is your concern, because there will be huge changes to infrastructure that are required in all of this. But we are never going to manage it if we do this in competition. It needs to be a team effort, and that's everything from power companies through to policy and regulators, through to engineering product. Everybody needs to be working together and with society to do this, not against each other.
Thank you. And I'll have a very, very quick comment from Yves.
Yeah, I know there are also fake news, and we know that we have to fight against fake news. And I think it's part of the problem we are facing to engage people to change the situation.
Thank you. I'm going to take one final question before we end the session, which is about the new German coalition government who announced an accelerated phase out by 2030 instead of 2038 for coal. With nuclear out of the picture, how can they succeed in achieving net zero while they'll have most likely to import gas and renewable energy? But that can't be sufficient, says the person who's asking the question. Any views from anyone on that? Yes, Christoph.
Well, I think that we have to realize that Germany and Europe as a whole will remain an importing region for clean energy, but hopefully clean energy. So in order to be able to really go out of coal altogether, base your own economy, our own economy on renewables, we need to start in earnest working on infrastructure, on relations, foreign relations, to import massive amounts of hydrogen and its derivatives from other countries which have a lot of sun and a lot of wind available, because in Europe we won't be able to do it on our own. And in Germany, we really need to rely on the delivery of all these objectives. So in soccer, you have a good saying, truth is lying on the pitch. So let's see.
Thank you. And someone else wanted to come in on that.
May I say friendly that I fully disagree, because it will increase the dependency of Europe. We are already very poor in energy. That is a risk that we are increasing the cost of energy, which consequence on our economy. So I'm really not convinced by the development of importation being from green hydrogen or gas. That was my comment. But we could discuss later, Christoph.
I think, Becky, you had your hand up first there.
I also disagree. I think that if we have that as a model moving forwards, that will never be levelling up of society. We need to, if you think about what that means we outsource all of our carbon emissions really to elsewhere, and that we rely on that energy, and we have a high-tech, high-energy economy that is driving technology, but we import that energy from outside. And I just can't see that. I think we need to reduce energy demand, and I think we need to look at how we generate sufficient energy to manage our own economies.
And I will give the final word to Peter.
Yeah, I think this is an interesting question, in particular in the sense that the European countries are so different. So we have our particularities, which may lead to different paths for different countries. But indeed, the German experiment, I think it's interesting in the sense that will definitely need a lot of new technologies. That would need engineers to solve intermittency questions, variability, and we will see more work on flexibility. So from the innovation point of view, definitely this huge transition that Germany is doing, that will require a lot of engineers. It is really where we need engineers, economists, and behavioral scientists to work together. And I would wish success to the German transition, and that may perhaps we could also benefit from the experiences that they definitely have.
Thank you. We will stop there because we're out of time, but thank you so much to all our speakers for such an honest discussion. And I think it's good to get some different opinions. Personally, it's nice to see that. We're going to take a short break of just under 10 minutes. So we'll reconvene for our second panel, which will be, and we'll look at how we apply some of these concepts that we've heard about this morning within the built environment sector. So please join us again at 11:25 UK time, 12:25 Central European time. So I will see you again shortly.